Today we're going to continue our problems out of the linear algebra chapter of Gunning's An Introduction to Analysis. Question 6 reads as follows. Find 2 by 2 matrices A, B for which AB equals 0 and BA does not equal 0. Take a couple seconds to try this out for yourself. Then we'll get on with the hint. Then we'll give you the solution. Alrighty then, so for some hints, I think it's easier to consider these transformations as from R2 to R2 and not to try to just do computationally by plugging in numbers into a calculator. Instead, try to do it graphically or using your intuition to think about R2 and the transformations themselves. In particular, what's the relationship between A and B for these set of relations to be true? Alright, so let's continue. So for AB to equal 0, then that means that the image of B is a subset of the kernel of A, because it sends everything within the kernel of A, so that everything gets sent to 0 by AB. But for BA non-zero, it means the image of A is not a subset of the kernel of B. So let's just take some easy examples. Let's construct the kernel of A to just be something like the set of all the y component, or 0, y, will always get sent to 0. So that means we put the second column of our matrix A to be 0. And then if we want our matrix B to have that as a, the image of B to be that, well, we want the image of B to be within the kernel, and this is a one-dimensional kernel, so it needs to send everything to that. So we need a matrix that sends the x components to 0, and then the y components just themselves. And finally, that will make it such that AB is equal to 0. And now we just need BA does not equal 0, so we need the image of A is not an element of the kernel of B, but we see the kernel of B is all of the x vectors. So if we do something like 1, 1, which preserves the x component, so part of it gets sent to 0, but also leaves a y component, then this will not be sent to 0. And you can confirm that AB is equal to 0, 0, 0. But BA is not that, and as a matter of fact, it takes all the x components and sends them to y. We could check that because we see that A sends the x components to the x components and then the y component to whatever the x component was. Namely, it sends x comma y to x comma x. And then we see that B will preserve the y component, the second component, and delete the first. So this is 0 comma x. So that's our net transformation that looks like this. So BA is non-zero, and then we've already explained why AB is 0, so we're done. Thank you for watching.